Hello and welcome. In this knowledge clip, we will explore the concepts of symmetric relations, asymmetric relations, antisymmetric relations, and equivalence relations. These relations help us understand how elements in a set can be compared or grouped together based on certain properties. Let's begin with symmetric relations. A relation R on a set A is called symmetric if, whenever an element A is related to an element B, then the element B is also related to the element A. In other words, if the ordered pair AB is an element of the relation R, then the ordered pair BA must also be an element of the relation R. For example, consider the relation is a sibling of. If Alice is a sibling of Bob, then Bob is also a sibling of Alice. Therefore, this relation is symmetric. On the other hand, the relation is greater than is not symmetric. If 5 is greater than 3, then it is not true that 3 is greater than 5, so this relation does not satisfy symmetry. Now let's discuss asymmetric relations. A relation R is called asymmetric if, whenever the ordered pair AB is an element of the relation R, then the ordered pair BA is another element of that relation R. In other words, if A is related to B, then B cannot be related to A under the same relation. For example, the relation is a parent of is asymmetric. If Alice is the parent of Bob, then Bob cannot be the parent of Alice. However, it is important to note that not every relation is asymmetric. Some relations are neither symmetric nor asymmetric. Next, we have antisymmetric relations. A relation R is antisymmetric if, whenever both the ordered pair AB as well as BA are elements of the relation R, then A must be equal to B. This means that the only time two elements can be related in both directions is when they are the same element. For example, the relation is less than or equal to is antisymmetric. If A is less than or equal to B, and B is less than or equal to A, then A and B must be equal. However, a relation like is a friend of is not antisymmetric because two distinct people can be friends with each other. Finally, let's look at equivalence relations. These relations help us group elements that share common properties and are therefore equivalent to each other in some specific regard. A relation R on a set A is an equivalence relation if it satisfies three properties, which are reflexivity, symmetry, and transitivity. A common example of an equivalence relation is the relation has the same birthday as. Let's check if the three required properties hold for this relation. Obviously, Alice has the same birthday as Alice, and therefore the relation is reflexive. Also, if Alice has the same birthday as Bob, then Bob has the same birthday as Alice. Therefore, this relation is also symmetric. Finally, if Alice and Bob have the same birthday, and Bob and Charlie have the same birthday, then Alice and Charlie must also have the same birthday, making the relation transitive. Since this relation satisfies all three properties, it is an equivalence relation, and we can use it to group elements. In this case, we can use the has the same birthday relation to group or segment people based on their birthday. That's it for symmetry and equivalence. Thank you for watching and see you next time.